Good morning, good afternoon, and good evening, everyone. My name is Bryan Tan. Allow me to present to you our paper titled The New Design of Automated Baggage Loading at the Airport. Let us start with a little bit of introduction. The airline industry has been rapidly growing for the past 2 decades. If it wasn't for the pandemic that struck earlier this year, we would have seen a record high in passenger volume. Unfortunately, the pandemic happened, and we are in an all-time low in passenger volume in the last 2 decades. However, vaccination is in sight. Perhaps some form of normality would resume, and that the industry will continue to grow again. Along with them, passengers bring baggage. More passengers means more baggage. Passengers bring carry-on baggage and bulk baggage. Our research is only interested in bulk baggage, baggage that has to be checked in. Bulk baggage can be divided into 3 types: outbound, inbound, and transfer baggage. How are baggage processed at the airport? Well, typically for an outbound baggage, they are first checked in at the check-in counter, or as is very common nowadays, at the self-check-in counter. From there, the baggage enters the baggage handling system of the airport, and it undergoes what it's called whole baggage screening. This is where illegal substances, items, or potentially harmful items are screened and removed from the system. From there, the baggage is checked if it's an early baggage or an in-time baggage. An in-time baggage is a baggage that is about typically 2 hours to 15 minutes before its takeoff. Early baggage will be sent to the early baggage storage for temporary storage. A secondary purpose of the early baggage storage is in order to gather up all the baggages of the same flight to be sent out to the sorting station at the same time. For in-time baggage, it is sent straight out to the flight sortation system. From there, it will be sent to the air site for flight build. Flight build is where the baggage is loaded onto a unit load device, a ULD, or a baggage cart. Baggage carts are used in the loading of narrow-bodied aircrafts, such as the 770 or the 760. For wide-body aircrafts, there are specific containers called unit load devices. Wide-body aircrafts are such as the A330 and the A320. In the flight build is where our design comes into play. The proposed automated unit load devices will replace the old ULDs. The new automated ULDs would have omnidirectional conveyors built within it. And within it are 3 layers of such a conveyor that is capable of rising, elevating in the vertical direction in order to load the baggage within it. However, a downside in this design is that with the built-in conveyors, it means that less baggage can be loaded into the ULDs. For standard LD3 unit load device, it can usually have capacity of about 40 pieces. However, with the added conveyor, it's expected to drop to an estimated 32 pieces only. To further and automate our system, we are introducing the use of an automated tug. It is basically an automated guided vehicle, so it's manless and is able to direct itself based on connection with the central computer, which tells it where it has to go and where it has to deliver baggages to. Within the automated tug is also the power supply that supplies the automated ULDs. Moving on to the research methodology. We first start off with the literature review, and then we move on to case studies, and then we run a simulation to test our design against the conventional manual, and finally we do a cost analysis to see how economically viable this design is. In our literature review, it was found there were no notable research conducted in this area until for the past 15 years or so. Among the earliest research we could find was done by Richardson Bridge and Otius in 2007, titled New Developments in Airport Baggage Handling Systems, where they proposed a baggage crane to replace the baggage cart in the loading of narrow-bodied aircrafts. Furthermore, the next research we found was done by Alexandra Bradley in 2013, titled A Comparison of Whole Life Cycle Cost of Robotic, Semi-Automated and Manual-Built Airport Baggage Handling Systems, where they discuss the benefits of an automated system. And it was found that an automated system for a major airport is hugely beneficial. Further on, Bryce et al. Wrote in 2015 a newly designed baggage transfer system implemented using events-based simulations, where they conducted simulations in order to test a baggage transfer system not for airports but delivery of baggage for other means of transportation like cranes and so on. Moving on to our case study. We begin our case study with the London Heathrow Airport. London Heathrow Airport is the most busiest airport in Europe in terms of passenger traffic. We have found that the baggage handling system in London Heathrow is highly advanced and automated in many areas. London Heathrow still uses manual loading in the loading of baggages into the ULDs. However, there is something interesting that they use, a movable platform called Stack at Ease. It is to enable weightless loading. It is basically a movable platform where the baggage handlers pushes the baggage onto the movable platform and moves it into the ULD and just have to push it off the platform again to load. Our next case study is on Amsterdam Airport Schiphol. It was voted the best airport in Europe for the year 2019 and is the second busiest airport in Europe in terms of air traffic. The flight building The flight building of baggage in Amsterdam Airport Schiphol uses what is called a coordinator assignment system, which means a coordinator is an experienced worker who delegates teams and resources to each station in order to load the ULDs. And all the loading of the baggages are done by hand manually. So in here we can see that one of the world's best airports still rely on traditional manual labor in the loading of baggages into ULDs. Moving on to the simulation. For the simulation, we simulate the building of 170 baggages. For the manual, 6 baggage handlers are assigned and 42 pieces is the capacity of the ULD. And for the automated, we only use a single-sided picking and the ULD capacity is 32 pieces. The duration for each activity for the simulation is as shown here in the table. And on the other side, we have the simulation results. The mean time to load a single baggage is shown, and the mean time to fully load a ULD. Take note that the manual is the capacity of 40 and the automated the capacity of 32, hence the large gap. For 170 baggages to be fully loaded, the mean time taken for the manual is 29 minutes, and for the proposed design it took 23 minutes, almost a full 6 minutes difference. Moving on to the cost analysis. Relative cost is used to compare the both designs. And take note that only direct cost is taken into account. Indirect costs were not taken into account. It is found that the operation cost of the proposed design is about half of that of the current manual design. And it was found that it takes about 2.2 years to get a return on investment to break even. And after that, we should see savings from the use of the automated design. Now to the conclusion and potential future research. In conclusion, this research area is relatively new. It's only been around for about 15 to 16 years. Many airports, major airports such as the Amsterdam Airport Schiphol, have not fully adopted technology into this section, although they do have a highly advanced and modern baggage handling system at the front. The proposed design is capable of loading ULDs up to about 19.3% faster than the conventional manual. And the cost of switching to the proposed design could be recovered after about 2.2 years. In potential future research, we encourage the investigation of using the same equipments to help in the loading of baggage in narrow-body aircrafts. We would also encourage further research in the parking of aircrafts, or currently the tugs which are being replaced by the design is used also in the parking of aircrafts. Furthermore, the design proposed only addresses the issue of loading baggages into the ULD, but it does not address the issue of loading the ULDs into the aircraft body itself, which still requires manual labor. Perhaps airlines and airport operators could collaborate together to further fund more research in this area, as the state-of-the-art system would benefit them the most. That is all, and I'd like to give special thanks to Alvin Sutanda and Muhammad Idham for their contributions to this research. That will be all. Thank you for your time.